Alright, so we've had a little look at momentum, and we've decided that it's pretty straightforward. So let's do an example. I've got a ball, A, 4 kgs, and it's moving at 2 meters per second. That way. So it's actually got a momentum, if we do P, of 8. What are the units for momentum? We didn't decide that. So, but they're obviously mass times velocity, or kilogram meters per second, right? Now, it smacks into a ball there, we'll call it ball B, which weighs 1 kg. Right? Now, the thing is, I can say whatever I like about this collision. Collisions are complicated, and I have to make stuff up sometimes. So let's just do a one-dimensional collision where that ball now races off in that direction at, I don't know, 4 meters per second. Now, before the collision, that's after the collision. Before the collision, that ball B was just sitting there, no velocity, so no momentum. So the total momentum in the system before the collision was 8. So after the collision, the total momentum has still got to be 8 kilograms meters per second. Now, after the collision, we know B is doing 4 meters a second and 1 kg. So it's got a momentum of 4. So that means ball A, because that was ball B, that means ball A, the 4 kg ball, must also have a momentum of 4 meters per second, or 4 kilogram meters per second, to add up to the 8, which can't change. So for the 4 kg ball to have a 4 kilogram meters per second, it must only be doing a velocity of 1 meter per second. And that's the type of question you'll be given for a one-dimensional momentum problem. You'll be given that question where you actually have to work out maybe the velocity. They'll give you the velocity of one ball, they'll give you its mass, and they'll get you to work out the velocity of it. And you just got to make the momentum before the collision equal the momentum after the collision. So reasonably simple little problem. While we're talking about collisions, there are two types of collisions: elastic and inelastic. With an elastic collision, you'll see that energy is conserved. Since we don't have height here, we're just talking about kinetic energy. So the kinetic energy is conserved, EK. In elastic, EK is not conserved. Right? Now, most collisions, like say 2 billiard balls smacking on a billiard table, are, well, not most collisions, but a collision like that where you've got no deformation in the structure, they don't stick together, very little heat, they're nearly elastic, very little energy lost. A collision where the two objects stick together and then have the same velocity is the perfect inelastic. So objects stick together after collision with same velocity. That's perfectly inelastic. So what we'll do, we'll leave this one here. We'll do an inelastic collision in the next video.